So let's do something a little bit more interesting and actually use that Scala IDE that we installed earlier. What we're going to do is take a real-world data set of movie ratings and analyze it using Spark. So we'll break it down into how many 1-star, 2-star, 3-star, 4-star, and 5-star ratings exist in this data set, as if we were going to generate a histogram for it. So to get started, let's create a directory to keep the project for this course within. I'm on Windows, so I'll just open up a file explorer here and go to my C drive and create one there. Click on New Folder, and let's call it Spark Scala. You can put this wherever you want. If you're on Mac or Linux, wherever you normally create new directories within your profile is fine. Let's open that up so we have it handy. All right, so let's go and get that data first. To do that, let's go to grouplens.org, just like that. And this will take you to the website for the Movie Lens dataset. This is real data collected by real people about their ratings for lots and lots of movies, and they keep it updated to this date, actually. This group is actually instrumental in research and recommender systems, but that's another topic for another course. Click on the Datasets tab here, and you'll see what they have to offer. We're going to just use the 100K dataset here, so let's scroll down to that. Older datasets, Movie Lens 100K dataset. We're choosing that because we're going to be running this locally on your desktop and not on a big cluster, so we don't want our data to be too big at this point. It's also a nice stable release where we know what to expect. So go ahead and click on the ml-100k.zip link there and let that come down. It's pretty small. Open that up and let's decompress it. Right-click and extract all. So let's take a look at what's inside of here. If we crack open that ml-100k folder, you can see this is the data set itself that contains a bunch of different files. The movie ratings data itself is in the u.data file, and that's just a text file where each line represents a rating for a given user, movie, and the actual rating value and timestamp of that rating. There's other files in here as well, such as u.item, that contains information that maps movie IDs to their actual titles, so you can actually read that in a human-readable format and understand what these identifiers really mean. But anyway, let's take this folder, go back up a level, and copy that ml-100k folder. Just going to select the folder and hit Control-C. Go back to the folder that we made for the course under C, Spark Scala, and paste it in there. Control-V. All right. Next, let's get the course materials. And that's going to include all the scripts and data that we're going to use within this course, except for Movie Lens. We just don't have the license to allow us to redistribute that Movie Lens data as part of the course itself. But for everything else, head on over to media.sundog-soft.com/SparkScala and pay attention to capitalization there. It's capital S's there. That does matter. /SparkScala3.zip, just like that. Again, no typos. Pay attention to capitalization. It all matters. And that should come down, and let's again open that up. Show in folder, and we'll right-click and extract that as well. All right, so this is basically where we're going to pluck things out of as we go through the course. So just remember where this directory full of all the course materials is so you can come back to it later. As we go through the course, we're going to be importing scripts and data from this folder into the project itself. So just remember where it is for now. Next, let's actually open up that Scala IDE that we installed. So I'm done with that browser for now. Let's go to where we installed that. That was under C Eclipse, as I recall. And to make life easier, you probably want to have a shortcut to this handy. So you can just right-click and drag that to your desktop if you want and create a shortcut there so you can get to it more easily going forward. Go ahead and open that up. And for our workspace, we're going to specify that directory for the class project that we just made earlier. So let's hit Browse and find that Spark Scala directory that we made. So that's going to be under my C drive. This PC, C, Spark Scala. And click on Launch. All right, let's maximize this window so we have more space to look at. And let's go ahead and create a project for our course here that we'll work within. So follow along with me carefully here. Every little step matters, every little detail. So let's start by going to File, new, and then Scala project. We need to give this project a name. How about, I don't know, Spark Scala course. And click Finish. All right. Next, let's right-click on that and create a package within that. So just right-click on Spark Scala course, and then we'll say New Package. And even though it says it's a Java package, it will really be Scala under the hood. But like we said, Scala compiles to Java bytecode, so it's all the same thing as far as Eclipse is concerned. We need to give this package a name. And if you're familiar with Java naming conventions, you usually take your domain name of whatever organization you're in and flip it as sort of the start. So I'm going to set the name of this package to be com.sundogsoftware, because that's a website that I own, .spark, and that'll just be the name of the package itself. Click Finish. All right, and now we have a package within our Spark Scala course project. All right, next we need to actually put some stuff into this package. So let's right-click on that package that we just made and say Import. Select General, open that up, and select File System, and click on Next. Now we're going to browse to the materials for the course where we downloaded that to. So that's still sitting in my Downloads folder. Just go to wherever you put that. And there it is, Spark Scala 3. And it's in that subdirectory there. Let's go ahead and open that up. And you should see this list of all these scripts and data files for the course itself here that we can now choose from to import into our package. So we're going to be working with the ratings counter.scala file here. Let's find that and check it off. And click on Finish. All right, so now we can open that up and have a look at the code if we just double-click on that ratingscounter.scala file that we just imported. Not much to it. We'll walk through what it does later, but for now, just trust that this is Spark Scala code that counts up how many ratings of each type we have. Now, let me call your attention to these nasty-looking red X's. These do mean that there is some sort of a problem preventing this code from compiling that we need to resolve. And you can always just go to the Problems tab here and open them up and see what they are. It turns out that the immediate issue is that we have not actually included the packages for Spark itself into this project. So we have all this Spark code, but it has nothing to link against. It doesn't know where Spark lives yet. So let's go and take care of that. To do that, just right-click on the Spark Scala course project. And we're going to go to Properties. And from here, click on Java Build Path. Now we need to add all the jar files for Spark itself. So let's click on Libraries tab here and say Add External Jars. Now we'll navigate to where we installed Spark, and for me that's under C Spark. Navigate to the Jars folder, and just click in there and hit Control-A to select everything, and go ahead and import all of the jar files for Spark into this project. All right, we'll hit Apply, or we could just hit Apply and Close. That's easier, huh? And now, if we give it a second, you'll see that those red X's went away. That's cool. So that means everything has compiled successfully, and we should be able to run this thing now. Very cool. However, there is one more thing that might have gone wrong, depending on when you're running this and what versions of Scala and Spark come out in the future. If you are seeing error messages about incompatible version of Scala, let me tell you where to go to check on that. So if you read the release notes on different releases of Spark, it will say that it's compatible with a given version of Scala. With Spark 3, currently it supports Scala 2.12, but maybe there'll be a Spark 3.5 or something down the road that takes Scala 2.13 or something, and you might see something about an incompatible version. If you do, just take a note of what version it wants in that error message, and we just have to change our project to use that version of Scala instead. All you need to do is go back to the project properties. That's by right-clicking on Spark Scala course, and click on Properties. And from here, go to Scala Compiler. This is where you can specify which version of Scala you want to use. So if I wanted to override that to a specific one, I could say use project settings and change that to a specific version of Scala if I needed a different version for the version of Spark that I installed. It turns out that Spark 3 works just fine with the default setting here of the latest 2.12 bundle of Scala, so we're good. We can leave that the way it was. Moving on, let's actually run this thing, yeah? So To do that, just go to the Run menu, and we'll say Run Configurations. Kind of doing this the hard way just to illustrate things, but we'll do it this way for now. And we're going to select a Scala application. Double-click that. Give it a name. Let's call this, I don't know, ratings counter. And we need to specify where the main class is. That will just be com.sundogsoftware.spark. Whatever the main class of this project is, in this case, ratings counter. So type that all in exactly as shown, and then we can just hit run and see what happens. Holy crow, it worked. That's awesome. So how do we interpret this output here? That was pretty quick too, right? So it chugged through those 100,000 ratings using Apache Spark, and if we were on a cluster, it could have actually parallelized that computation across different nodes in the cluster. If we had a much larger data set, that might have been beneficial. But we see here that we had 6,110 one-star ratings, 34,174 four-star ratings, for example, and 21,201 five-star ratings. And already we're getting some meaningful information out of this data, right? We can see that people are really reserving one-star ratings for the worst of the worst. It has to be pretty bad for people to give it a one-star rating. And the most common rating is actually a four-star rating, with 5 stars not being as common as you might think. So people weren't quite as generous as they might be in other settings when rating movies on the MovieLens website. Pretty cool stuff. So there you have it. You actually successfully ran your own Spark application using the Spark IDE, so it's all nice and pretty. And yeah, let's kind of walk through what's going on here at a high level. We'll go into this stuff in more depth later in the course, but just to get your feet wet, as it were, let's take a look at what's going on here. First, we declare the actual name of the package that we're living within here, and we import all these Spark libraries that we depend on for this job. For us, that's just Spark, Spark Context, and the Log4j class. Now, a little quick note here. We're kind of starting off with doing things at a lower level in this course, and we're going to work our way up to more higher level and modern ways of writing Spark code. But I do think it's beneficial to understand things at a lower level, given that Spark 3 does still support these APIs. They're there for a reason. Sometimes it makes sense to go at a lower level if you're doing something that's simple like this. So we have our main function here that lives within our ratings counter object, and that's the code that gets executed. What happens here is we start off by setting our logger to only log error messages. That could be redundant with our change that we made to our log4j properties file, but there are settings where that properties file doesn't get read in time. So we'll explicitly say here that we don't want a bunch of log spam as well. We then create a Spark context object, and this means that my Spark context, my Spark environment, if you will, is going to be running on my local machine here, and that star means go ahead and use every core of the machine that's available. So it actually could be parallelizing this work across the 4 cores on my CPU, even if I don't have multiple machines in a real cluster. And we give it a name called ratings counter. Now with one line of code, we use that Spark context object to load up our data set. The u.data file, remember, is the ratings data itself. And then we call this map function on the resulting what we call RDD, and we'll talk about RDDs in much more depth shortly. But for now, just know that it's you can think of it as sort of a database or a data frame. We're going to take that set of data that we imported from that raw text file and map it to a specific format. So right now, that lines RDD just contains individual lines of text, and we need to split that up into their individual fields. That's what this map function does using what's called a lambda function, to actually take that, convert it to a string, split that string up based on tab characters, tab delimiters, and extract the second field of that and take that as the rating value itself for that line. So with one line of code here, we've taken all of the raw input from our ratings data from MovieLens, extracted the ratings column from it, and created a new RDD called ratings that just has that ratings data. At that point, we can just say ratings.countByValue. That uses a built-in function to actually count up how much time each individual distinct value occurs within that RDD. After that, we just sort the results and print them out, and that's all there is to it. So again, we'll talk about these operations in much more depth, but I just want you to start to wrap your head around what Spark code looks like and how it works. So again, congratulations, you got your first real Spark application running within the Scala IDE. Cool stuff.